Hey guys, it's Jock. We're here to remember about electric force, aka FE. The purpose of today is to give you a brief and good introduction over it for about 5 minutes and have you remember. FE is the amount of electric force, attraction, or repulsion between any two charged objects. I'm putting charged objects in quotes because you might remember, even though something's neutral, it will probably still attract because it has polar regions. We'll remind ourselves of that in a couple minutes. But yeah, so FE is the electric force. It is strong, not as strong as the strong electric force, but a lot stronger than gravity. Mathematically, you need to have two charges or two regions. We call them Q1 and Q2. Each one is the charge of that region. Charges are measured in coulombs, which is C as well. Remember that coulombs are really large. For example, if there's like 2 coulombs in front of you, it'd be really shocking. That's why we usually use microcoulombs, 10 to the minus 6, and nano, 10 to the minus 9. These are on your formula sheet. So you usually see numbers in 6 microcoulombs, 12 microcoulombs, that kind of stuff. Distance matters well. It's over d squared. The farther away they are, the less they're going to attract or repel. We have to use absolute value, you might remember, because of the fact that negative doesn't matter here. Finally, k is the constant, kind of like gravity. It's 9 times 10 to the 9th. So this is our basic relationship between two charges. Now, a couple things to keep in mind as well. We kind of talked about it before, but even neutral things usually feel some kind of force if the charges can move inside of it. So you might remember if we bring a positive object nearby, something that's neutral but charges can move, like metal, for example, the positives stay in place, but the negatives will either be attracted or repelled. In this case, they're attracted, making the left side negative, the right side positive. Both of them feel a force. One retracts, one repels. But since the closer one is closer, it is always stronger because of the d squared. It doesn't matter if it's positive or negative. It will always attract. So this tells you that neutral things will attract to charged things, but not as strong as if they were overall the opposite sign. And finally, let's take a look at an example. Let's say we have 1 coulomb and 2 coulombs separated by some distance. If you were to let them go, a moment later, these two things would actually repel from each other. I'm about to draw that in a moment later. Now, they're going to feel the same electric force, but since the 1 coulomb might be, lighter, let's say, I don't know, actually it's not quite true, it's going to move a little bit further. But for the most part, what's going to happen is the electric force is going to go down as they repel more and more. And it's going to look like that. As you get further and further away from each other, the force becomes less and less and less, but never actually goes to 0 because of the fact that they're super far apart. So the acceleration goes down on each one, but the velocity goes up. And you're asking why? Because even though you're getting less and less force, there's still an acceleration there, just getting less and less, which is why we have this asymptotic value. And that, my friends, is the basic idea.